Hello and welcome to a brand new episode of the Mission Shunya podcast. This is the first episode of 2021, and here's wishing you and your near and dear ones a great year ahead. And by any chance, if this podcast happens to be a newer resolution of listening to some interesting podcast, welcome on board. Shunya means zero in the native Indian language, and this podcast covers stories related to the global zero carbon transition. Once in 2 weeks, I bring to you an episode, mostly an interview with a special guest who also believes in sustainability and the zero carbon transition, or whose work has a significant impact in the sector. This is episode 47, so you can check the podcast playlist to find the previous episodes, or you can subscribe or mark this podcast as a favorite so that you get notified when a new episode is released. This week, the discussion is around the impact of climate change on the renewable energy generation. As you are aware, renewable energy generation is intermittent because of its inherent nature. But did you also know that climate change can play a role in it? On this episode, our guest, an expert from REConnect Energy, joins me on the show to share the new evidence that has emerged in 2020. You'll get to hear about the importance of forecasting and scheduling of renewable energy and the new technology and tools that can help us be better prepared in handling the unpredictable or rather unavoidable consequences of climate change. So without further delay, please join me in the conversation. Hello Asim, welcome to the Mission Junior podcast. So Asim, before we get to the topic, why don't you give us a brief background about your work and what you do?
Hi Girish, glad to be here. And coming on to the work that I do, I'm working at REConnect Energy, where we are working on artificial intelligence and weather services for the energy industry. And my role in that is largely around the development of the technology, where we focus on R&D aspects of artificial intelligence development. And a few years ago, I think 3 years ago, we gotten on board a few meteorologists to join us to work on the weather side of it as well. So that's going on well also. But yeah, that's pretty much it. We're working on the AI and R&D side of the work.
That's very good. That's very interesting to know that you're getting meteorologists on the team. So how important is to have this kind of skill sets in the future, especially in dealing with renewable energy?
I think for energy industry in general, it's quite a critical thing because earlier the way we were working was we were relying on outside third parties to deliver us the weather data and the weather services and also even the weather expertise. But year by year, month by month, we started to realize that this aspect of it is absolutely critical to the energy industry. Especially so when we have increasing numbers of renewable generation added on to the mix, where the generation is largely dependent on the weather, and even on a day by day on an operational basis it's a critical requirement, but also on longer term to medium term basis, where over a few months to over a few years the larger patterns that are developing in weather and in climate are starting to have an impact on the industry. So I believe it's absolutely critical, and without this there was no way that we could move ahead, so we had to add it on.
It's interesting that you mention about the external agencies. What are the external agencies that you're referring to and how different is it? For example, I understand assessment is done typically by having wind masts installed in multiple sites. Solar assessments, again, few sites have solar radiation collected. But what were the other external agencies that we were dealing with?
Largely it works like this. The because weather being a very high investment project, so to say, the major agencies around the world are usually government funded. So these are the ones I'm talking about. Like even in India, we have IMD, the Indian Meteorological Department, and similar to this, we have in America NCEP and NOAA, and in Europe we have ECMWF. Australia has a meteorological agency. Japan has a very advanced meteorological agency. So these are largely government funded agencies who put in a lot of money, because the resource requirement here is because they need very high performance computing, or what we call supercomputers. Along with this, you need to have a very wide ranging ability to collect weather data on a daily, sometimes multiple times a day. This requires a lot of investment in terms of money and people. So this is largely done by the government agencies. This is the first layer of it. So this is where it all starts, where they start processing weather data and so on. Further from this, there are private companies and a lot of other companies who are coming in now, who take this data, and from this source global data, which is run by the supercomputers by the national agencies, and then they further process it, bring it down to a level where it is more useful to end use cases like our own, for example, for renewable forecasting. This is largely how the climate and weather modeling works. When it comes to wind resource assessments, that's a slightly different area where it forms a niche within the sector, and there's a few companies really focused on it where they install met mass at particular site, and they're looking at historical data for a bunch of years and trying to extrapolate based on that what may be the future cases for the next 20 years from an investment planning point of view, or to identify sites where it is best to install wind or solar farms. That's a niche within the sector, and within that also there have been some developments now where they are looking into using lidar technology to get a much better profile of the wind flows at multiple heights and so on. So that forms a niche. It's not what we focus on ourselves at REConnect Energy. We are more focused on the weather patterns, the weather modeling, as well as the climate.
That's good to know about the brief background. I mean, the fundamentals of weather assessment and weather monitoring, because when we get into the particular topic, I'm sure this will come in handy. Now, before we get there, Asim, your expertise also is very significant in wind assessment, wind generation assessment. But for the listeners, I mean, I'm quite aware of how things work in wind, but would you like to kind of briefly tell about how different wind sites are classified and why is it essential to have better performance in certain sites? What is it? What is the impact of a hub bite make and things like that? A brief short overview of that.
Yeah, absolutely. I mean, the way it is, if we look, say, at a country level, there is a lot of potential in India. Say, if we talk about wind potential, I believe the MNRE, the Ministry of New and Renewable Energy, estimates that there's about 300, close to 300 gigawatts of wind potential in India. Now, this wind potential is distributed across the land at multiple locations. And when, say, an investor or a generator wants to put up a farm, they have to make the decision of where do we put this farm up. And that there's a lot of factors at play here, including policy and power grid related concerns that they may have. But among all this, the chief concern that they would have is where do we put up the site so that we can maximize the gain from the wind flows. And for this, they need to make a decision on the siting of the wind farms at considering all different locations. And for this is where you have wind resource potential maps of India, which are identifying the high wind flow zones, the low wind flow zones, the medium wind flow zones. And based on these maps, you can do further deeper analysis by, if you say you pick up a region of Gujarat and Tamil Nadu have the highest capacities of wind installed, and that is largely because of their proximity to the coast, to the oceans, and they have uninterrupted wind flows coming in from the sea surface onto the coast. All of this plays a role in the decisions that are made by the investors and the generators. And this is largely where the wind siting also comes into play, where you have high wind sites, low wind sites, and so on. And based on the sites, and along with this, I'm sure there are also considerations of the land and the kind of soil that there is in terms of what kind of structural integrity of the wind tower turbines itself that need to be put up. And based on this, they make classifications and they make decisions on what type of turbine should they put up at what height. There will be regions where, like for example, in Maharashtra and Karnataka, we see this that there's a lot of hilly regions, and in hilly regions, what happens is largely the wind flows in the valleys are quite smooth. So sometimes they want to put it in the valleys, but in other cases they would want to place the turbines on the top of the hills just to maximize the generation, because you get higher wind speeds the higher up in the atmosphere you go. So they would like to be higher up. So these are the kind of wide-ranging considerations that go into wind siting and identification of the locations where wind turbines need to be put up.
That's very apt and very short because, as you rightly said, the higher up you go, the higher wind power that you can, the wind speed that you can tap into. Because mathematically, I think the wind generation potential is like the cube of the wind speed. So,
Yes, that's correct. Yeah.
so the higher the hub height, the more generation that you can tap into. Now, coming into the particular topic that we want to cover in this episode is wind generation trend that we saw in 2020 across India, because this was a year when the wind generation was far off from what was actually forecasted and what was actually projected.
Yeah.
Where did it all go wrong according to you? Where were the early signs?
Yeah, so getting into this year, I mean, it's hard to say if there were signs or if it would have been possible for us to identify the signs. I mean, yeah, just to provide a context around this, what happened this year was an anomaly that so far, so in a normal situation, what we see in India is that there is a monsoon period, and this monsoon period is quite critical to India, not just from an agricultural point of view, but also for the wind industry. The reason for this being that in India, majority of the wind flows happen in this monsoon period. So it's this June, July, August period that we consider. And the meteorological reasoning behind this is what happens is that usually at the pre-monsoon period is kind of also where the summer onset happens, and because of this we start to see a temperature difference between the land temperatures and the ocean temperatures, and this in turn causes a pressure differential. So you end up with having a lower pressure region across the Indian lands, especially the northern plains, and a higher pressure developing over the Indian Ocean. And because of this pressure differential, you start to have wind flows from the Indian Ocean all the way up to the northern plains of India. And these winds, as they flow across the Indian Ocean, they start carrying moisture in them, and then that's what brings the monsoon. But associated with these wind flows are also what drives a lot of the wind generation in India. And this year, what we saw was that the wind generation, especially in this part of the year, the June, July, August period, was seen a drop of about 24 to 25% overall. And this was very surprising because every year, all the generators, the entire industry is expecting this year to be a high revenue, high generation period. And suddenly you start seeing, very low generations. And that kind of led to an inquest on what happened. Why is this happening? What is the cause of this? And we did an analysis at our own organization around this, and what we found was that the reason for this has been associated with some of the weather anomalies that we have seen this year. So largely, India experiences post-monsoon cyclones, which is a common occurrence. What we saw this year was we had pre-monsoon cyclones. So if you remember, it was in the news that Cyclone Nisarga and Cyclone Amphan made landfall this year in the months of April and May.
Exactly.
And this was a very unexpected thing because this normally doesn't happen around this time of the year. But what this led to was that because of these cyclonic activity, of which there was a lot of economic damage associated with this. But in particular, if we look at the impact on the wind industry, because of the rains that came in because of these cyclones, the temperatures over the northern parts of India, in the northern plains, dropped. So what we saw was that there was a reduction in the temperature. What we would see higher temperatures over the summer period, these temperatures were lower by about 1 degree. And at the same time, we are seeing sea temperatures also dropping rather than increasing. And this has led to a anomaly where the wind flows have not really happened as they would in any other year. So compared to last year, so I mean, as per our analysis between the northern region, western region, and southern region, if you look at independently, we've seen between 11 to 17% drops in generation. So yeah, this was what has caused the anomaly.
That's very interesting to know about the impact of a certain period of cyclonic that had an impact over the season, because this year's monsoon was, close to normal or a little more than normal in some regions. Like for southern regions, it exceeded the forecasted thing. But even in spite of having a good monsoon, the associated wind patterns were not, correlated. So,
Here I'd like to add this one point that it's you're absolutely right in saying that we did have a normal monsoon. However, the definition of it is something that we need to look into, because as per normal criteria, what qualifies as a normal monsoon is basically a certain level of rainfall that needs to be received over the lands. And by that metric, yes, we have had a normal monsoon. However, if we look at the actual patterns of the monsoon, what we have seen is that this rainfall that we saw in aggregate has been normal, but the distribution of it has been absolutely abnormal. So what we have seen is that there's been very, very heavy rainfall in certain pockets of India, which has caused flooding and so on. So in aggregate, if you look at the cumulative effect, we've had, more than sufficient rainfall to classify it as a normal monsoon, but the distribution of it has not happened. So it has not been that the rainfall has been distributed across all parts of the country. There have been parts which have been experiencing droughts, whereas you look at the eastern coast of India, close to West Bengal, Bangladesh, they have had extreme rainfalls, and even in Tamil Nadu recently, we've had extreme rainfalls, which is not normal, I would say.
very apt. You rightly had a point there. Now, talking in particular about the ocean temperatures, so the marine heat waves is something that you say has been a critical factor. Now, this factor, did you look into it over a period of time previously and then attribute? Did you have any correlation between the temperatures in the last few years compared to this year? Did you see any correlation there?
So there's been a lot of research done on this. One trend that we have been seeing is that if one of the works that we are currently engaged in is with the Council of Energy, Environment and Water, And in our work with them, what they have also pointed out is that there's been a decline in wind speeds over certain regions in India. So we looked at Gujarat, and since 1979 till date, there has been a steady decline in wind speed year on year. And the attribution of this, if we have to find causes related to this, we have to look much deeper into the longer term trends. And there have been reports which have been created by the Ministry of Earth Sciences in India, as well as the IPCC report that was published recently on climate change. And what they have been pointing to is that over time, there has been an increase in surface temperatures of the sea, especially the Indian Ocean. So if we look at Indian Ocean in particular, the rise in temperature has been 1 degree Celsius over the last 50 to 70 years, as opposed to if you see a global sea surface rise in temperature, that has been about 0.7 degrees Celsius. So on much longer timescales, 1 degree is a large number. And this being higher than the global average also points to this the fact that, over Indian Ocean, what we are seeing is it has been building up over several years. And this, the scientists believe, I mean, this is not something that can be claimed as a certainty, but there's a very high likelihood that this is being caused by what we say anthropogenic forcing, which is essentially saying, this is man-made climate change. The impacts that humans are having through the economic or industrial activity, that impact on the climate is what's causing the sea surface temperatures to rise. And this in turn is now coming full circle, and now that's having an impact back on the energy industry in the form that we just described, that the wind sector is facing the brunt of this.
That is really very scary. 1 degree rise in temperature, and if that proves to be right, if the studies are undertaken in a depth, I mean, that's really scary, because our target is to have about 1.5 degrees C by mid of the century. So 1 degree Celsius, and that's like 30% higher than the global average. That's really scary.
Yeah, I mean, the one caveat here is that the 1.5 to 2 degrees, I mean, 2 degrees is where it would start to get dangerous, and 1.5 degrees is the target that we have. That's for the overall atmospheric temperature. This in specific that I was talking about was the sea surface temperature. But you are absolutely right in saying that, this is a scary prospect, and it needs to be looked into much more seriously.
Exactly. As you rightly said, we have to look at it more seriously, because in the general perception, we all talk about renewable energy, solar, wind, and everything being good.
Mm-hmm.
But entire climate change is causing a wide range of fluctuations, even in forecasting, predicting, and assessing renewable energy potential. So that is really scary.
Absolutely.
And how did this sudden drop in wind generation impact the forecasting and scheduling of power? Because if India as a country is having a lot of influx of renewable energy in the last decade,
Mm-hmm.
so this variance in energy generation would have definitely caused some problems to the grid. What really happened?
Certainly. I mean, so there were two impacts. One was, as you say, the forecasting and scheduling was impacted. So what we have seen is that because of this, sporadic influx of winds, as I was saying, the distribution of the monsoon wasn't exactly normal, as we would say. And because of this, what we saw was that within certain sites, and this didn't impact every single site in India, but it did impact heavily towards a few sites, especially the coastal ones. What we saw was that they were seeing the generation patterns, which we would have normally seen last year in monsoon and this year, were quite different. And what really causes a problem in terms of forecasting on a real time or a short term basis, short term, what I mean by short term is basically 0 to 15 days ahead. In this period, if we were seeing a lot of wind gust events which were leading to high ramp ups as well as ramp downs, where there was a sudden rise in generation and then followed by a sudden drop in generation, this causes a lot of issues in forecasting. This made it a lot harder to forecast, and overall we have seen that the forecasting accuracies have also taken a hit by about 10 to 15% as compared to last year. And this is having a further impact because, as you know, within India, we have a financial mechanism linked to forecasting and scheduling, where if the forecast accuracies are not close to the actuals, the generators do have to pay a penalty, a financial penalty, to the government load dispatch centers. And this is having a secondary impact on them. So, yeah, I mean, there's one other impact of it.
That's right. As you rightly mentioned, the wind power generators, the developers, the independent power producers, they have a bigger impact, because all of them assess this like a 25-year project, and they have entire financial model is built around the generation.
Absolutely. And I'm glad you mentioned financial model, because this is another thing that we are seeing that's coming up, is because largely these companies, it's good for them, especially the IPPs and the generators, to have some kind of foresight in terms of their revenue streams for a few months in advance. and I'm sure a lot of them would have planned for higher revenues over this period of June, July, August, which didn't materialize. And because of that, their entire modeling for even for the year, and this we are talking about the medium to long term basis, is where they are having an impact here, where they are this year they have not been able to have a realization of the expected revenue inflows. Overall, I mean, the decline in generation, if you look from January to November period in this year, it has been a decline of about 5 to 11%. So it has been diluted when you consider the larger picture, because we have seen, because of the pre-monsoon cyclones, there were higher wind speeds at some points towards April and May. So over the year, it has been less, but the distribution of it has changed, and the revenue forecasting which they would have done would have certainly taken a hit.
Now, continuing from their perspective, I'm sure this scenario would have definitely had an impact on how they assess future projects, how they forecast and build financial models for the future projects. What would they take? What would be the risk factor that they would assume? So, do you see any emerging trends where they are being overcautious in the projects that they're going to develop in the future in terms of what they take as an expected generation? Do you think they are having a risk element there, increased risk element?
I believe so. I mean, we've seen also ourselves that we have had a increased number of inquiries in terms of seasonal forecasting, seasonal and sub-seasonal forecasting, where they are saying, can you predict and tell us what is going to be the generation on a month-on-month basis for the next 6 months or the next 12 months, so that they can do their own revenue planning better. This is one of the changes that we are seeing. In the wind resource assessment models, this is something that should be factored in, could be factored in, but the specifics of that will be difficult, because we were trying to do some modeling around this to try and understand, how frequently is this going to happen. I mean, we cannot say that this is certainly going to happen next year and the year after that. This may be a once in 3 year or once in 5 year scenario. But what we are seeing from the research coming in from climate change is that this is going to be an increasingly frequent scenario, that it is going to happen. Maybe not next year, but perhaps in the next 5 years. And after the next 5 years, the frequency of it will increase if we continue on the same trend. So this has to be factored into the investment planning also, where they are looking at 25 to 30-year period. They need to factor in, as per the normal resource assessment, if this is what their expectations are, then maybe they need to be moderated by considerations of these type of events. If you have 5 of such events in the next 15 years, then you have a lesser revenue realization. If you have 10 such events, it's even lesser. This has to be factored in, and I believe that will now begin to be factored in a lot more, especially in India. And this is not something that's specific to India. Last year, similar events were noticed in the US as well. So it is becoming a global trend.
Oh, that's very interesting, because I was going to ask you just that, because all through we have spoken about the condition from an Indian perspective. But what are the other trends that we have seen? You did mention about US. Was it the same kind of impact, the same reasoning, or was it because of different causes?
The root causes of it were largely similar, in terms of they also believe that it is climate change related disturbances which are causing this. However, the specifics of the meteorological phenomenon which led to these events in the US, I'm not particularly certain of, because I haven't looked at it in detail. But in my analysis of India, when I was trying to find, any precedents of this, I did find that Europe and US has also been subjected to this in the recent past. We're talking about the last 2 to 3 years, where they have had in the US especially, they had a drop in generation, I believe, in 2018 or 2019 as compared to the previous years. And they also believe that this is also, climate change related. And this, because it is something that we have started observing only recently in the last few years, not a lot of work and literature has been done on this. It's starting now to become a focus area, and I believe it will be a much more focused research effort, at least from a lot of the sector and academics as well.
We did talk about climate change being a critical factor. Now, as a technology company and as a person who deals with technology and the emergence of technology, AI, data analytics, and everything, so how are you bracing up for this change? Because, as you rightly mentioned, this is going to be a continuing factor. The trends are very clear that climate change is going to play a significant part in renewable energy. How are you bracing up for this change? What are you going to do to make sure the unpredictability is kind of taken into account and the risks are mitigated?
Yeah. I mean, uh, very valid point that you're raising. That, I mean, this has also caused a change internally within us, and the last few years, as I said, that we have started to have a larger focus on weather and climate aspects of it. So this is basically accelerating that process, where we are seeing that, we need to have a much bigger focus on weather and its impact on the industry. And here in this conversation, at least, we've been largely focused on the wind sector and the drop in wind generation because of this. The other side of it is also that, because of these changes, we are seeing a lot of extreme weather events, and this is having a financial impact on the industry. To give you an example, not too long ago, 18 months ago or so, we had one of our clients come back to us saying that their transmission assets were damaged because of a cyclonic event that happened in the southern part of India. And because of this, their transmission assets, which, as you know, are very expensive, high value assets, were totally destroyed. And they were really in a fix to try and recover these losses. And they had insurance for it. But even for them to claim the insurance, they had to go through a process of kind of proving to the insurance company that that event that happened wasn't because of poor design, but it is because of an extreme weather event, which was unavoidable. And for this, they had approached us, and we had done a larger analysis to try and prove to the company that this was in fact a small scale cyclone that happened in a very localized area, and led to the transmission assets being damaged. And this was one event that we worked for. Like this, there have been 3 or 4 other events which have happened. The couple of cyclones that we mentioned that happened this year, Cyclone Amphan and Nisarga, this had, I believe, in total financial damage of close to 1 lakh crore rupees. This is quite considerable, and this was actually, if you consider the one that hit the Maharashtra region, Nisarga, there was good fortune involved for us because, and I say good fortune, uh, uh, understanding that it wasn't exactly a fortunate event. However, this cyclone made landfall about 100 kilometers off Mumbai. If it had hit Mumbai instead of 100 kilometers away, the damage would have been much greater, not only to life but also to economic activity and property and so on. So these type of events are in turn going to have an impact on infrastructure, power infrastructure, road infrastructure, city infrastructure, and so on. This also needs to be considered, and this is one of the areas that we are focusing on as a company as well, where we want to have a much better monitoring, visualization, and mapping of such events, and try and be aware of any such events developing before onset, so that the utilities and the governments can be better prepared. They know that this is coming, and they understand what are the uncertainties associated with extreme weather events like this, which are going to happen more frequently. So this is an area of focus that we are developing now, and along with this, we are also creating a larger focus on seasonal, sub-seasonal, and multi-year projections of what's going to happen with the climate, and associated with that, what will be the impacts on the short-term weather phenomenon.
Well, although the events and whatever you mentioned in terms of what is likely to happen, although those look very scary, and I mean that's going to be the reality. But it's good on the other side that we have, or rather, we are developing the tools required to be better prepared to face the eventuality. Because I mean, it's not going to change, so at least we are better prepared, and that's good to know.
Absolutely.
Although the events that you mentioned are really scary, and
Yeah, yeah,
hope the impact is not as severe as it could be.
yeah. I mean, yeah, as a population, there was a point up until which we were talking about climate change mitigation, where it is absolutely critical to be focused on that and try and mitigate the effects of climate change. However, we have to recognize, that climate change is already here. It's no longer just about mitigation. We also have to think about adaptation, where we are seeing the effects of climate change now, and how do we adapt to them? And that's largely going to be, figuring out what the uncertainties are and managing those risks, because it is going to happen. It is happening already. We just have to accept it and then work on both sides of it, where endeavors like greater capacities for wind and solar are trying to mitigate the impacts of climate change. However, the effects that we are already seeing, we have to adapt to them, and that would involve a lot of weather modeling and being focused on the short term impacts of it, and trying to minimize the damage and loss of life associated with that.
Very well said, Asim. I mean, on a final note, we have spoken about all the things that could go wrong with climate change.
Yeah.
But on a personal note, Asim, what does sustainability, sustainable living mean to you?
I mean, sustainable living, I believe, is a personal choice. I mean, there's a lot of things that people can do, and it may be different things. We see a lot of media awareness around this, and a lot of ideas being propagated. A major one being, consumption of meat can be reduced, which I believe is absolutely true. It does have an impact, and the people who want to go that route, I have people within my team who, they've taken a pretty strict stance on this, and they said, I'm not going to consume meat because it's contributing to climate change, which is admirable. But there may be other people who do not want to go that route. So it has to be a personal choice, where if people believe that they can make a difference by flying less. The aviation industry has a major impact on climate. That could be another route that people consciously make a decision that, wherever possible, I'm going to try and not fly, maybe take a train instead of taking a flight from Bangalore to Chennai. That's going to help. Every little helps, and everyone has to be involved. So, yeah, I mean, I believe it can take different routes. It could mean, using less water so that the resources are conserved. And this could be done, right from the ages of 3 to 5 years old all the way up to 90, 100 years old. Everyone's going to have a different approach. Every little thing will help. So whatever people find comfort in, whatever they believe that they can do without impacting their own lifestyle too much, they should do. And above and beyond that, every little will help.
Wonderful. Every little act, every small action will go a long way. That's very well said, Asim. I appreciate taking time and sharing your views, sharing the work that you have done to this audience. So thanks for being on the podcast.
It's been a pleasure, Girish. Thank you for having me.
So yes, climate change is having an impact on the industry that is defined by intermittency and variance. What's worrying is the reason: an increased ocean temperature that are causing unseasonal cyclonic storms and changing the wind patterns. The impact is very significant. The developers who put their dollars into renewable energy projects expecting a certain annual generation are losing money because of the unpredictability, but they are also forced to pay penalties for deviating on the scheduled and causing instability in the electric grid. So the entire sector is bracing up for the risks associated with such events by being better prepared by using advanced tools, as we heard towards the end. To know more about the tools and solutions offered by Asim and his team at REConnect, visit REConnectEnergy.com. And the little action item, as mentioned by Asim towards the end, make sure even your act counts in this transition towards a sustainable lifestyle. Every small act counts, be it conserving water, segregating waste, or taking one less flight in a year, or even probably walking a short distance to shop. So every small act counts. Finally, take some time to write a review on Apple Podcast or any platform that you use. It definitely helps with spreading the message to a wider audience. It just takes about 30 seconds of your time to share the episode to 3 people in your network. A small but a powerful act that could go a long way. With that, signing off, this is Girish Shivakumar, and as always, thank you for listening.